Welcome to AsappJobs Lab. We bring you all possible solution of interview question, including most efficient one.
And now let's see how to implement a method which will reverse every k nodes of linked list. So as you can see in main method, we already have implemented few methods like add method, print list method. And if you see the implementation of this add method, so here you can see what we are doing. Basically, we are adding the element value at the end of linked list. So that's how we are building our linked list, right? So you can see that we are adding one, starting from 1 till 8, one by one. And this is the print list method which will be printing the linked list values. And if you see that implementation of this, so here we have written the code for this. And this is the method which we have to implement, in which we are passing head of the linked list and the value of k, as you can see here, right? So before implementing this method, let's run our program once. So you can see that this is our input list, right? 1 2 3 4 5 6 7 8 and then null. And as we are passing k is equal to 3, then our output should be 3 to 1 and then 1.2654 and then 4.287 and then 7 will point to null, right? So before we start implementing this method, I must tell you this, guys, that I have seen many candidates who will start implementing the method, targeting the actual problem itself, and there exactly they will get stuck, right? So in that case, I think the best way to implement any method is we have to create sub problems of actual problem, and we have to start solving those sub problems one by one. And that's why if you see our previous video, and there we have learned that this is a reversal problem. So we have to understand first that how to reverse the linked list, and then after that we can start adding some elements like the k value has given, then how we can use this k element and how we can manipulate with the existing code, and like that one by one we'll start writing the code. So having said that, we will start writing a code which will reverse the linked list. Okay, so as of now, forget about the k, even though we are passing k is equal to 3, but in initial phases we will just avoid k for a while, and we will just reverse our linked list, right? So let's do that. So in iterative method, we will follow basically 3 steps, right? And we have to have a 3 pointer first of all. So one pointer, which is a current pointer, which we already have declared here, as you can see this, right? So current is nothing but head now. So first thing first, what we have to care about is the boundary case. So if current is not equal to null, and if current next is not equal to null, then here we are going to write our logic. So this is a boundary case where if we are passing our input linked list as a null, or if our linked list is having only one element, so in that case we don't have to do anything, right? So this if condition will handle the situation. And now we will write those 3 steps. So before that, we will just see in whiteboard just for clear understanding. So in first step, our front will be pointing to the next element of the current. So this is our first step. Now we will reverse the current element next pointer to back pointer. So this will be our second step. And in third step, back pointer will point to current element, and that current pointer will point to next element. And these steps we have to do for each and every node of the linked list. That means this process we are going to stop when the current pointer will pointing to null, right? That means we will start writing while loop, and the condition would be current is not equal to null. Then step 1, our front pointer will be pointing next of current. So current next. And now this is a time to declare other 2 pointers, front and back pointers. We have not declared it, so it will be struct node and initially this will be assigning to null. Okay, now second step is current next is address of back pointer, right? So this is the second step, and now back pointer will be pointing to the current element. So this back pointer will point to the current element, and then current will point to front element, right? And once we come out from our while loop, then we have to assign our head pointer as in the last element of the linked list, right? Which will be first element of reverse linked list. So that will be, so when the current pointer will point to null, in that particular moment back will be pointing to first element of reversed linked list. Now head is pointing to the first element, and now let's see, after executing our algorithm, let's print our linked list. Let me copy paste these. Let's name it reversed list. Okay, and now let's execute it. Okay, so we are successfully done with that. We have reversed the entire list, right? Starting from 8 7 6 5 4 3 2 1 and null. There's another way to handle our boundary case where we will write if current is equal to null or current next is equal to null, then we'll return from here. And let's remove this part. Save it, and it should be working fine. It will reverse the list. So now we have solved our first sub problem, right? Reversing the linked list. That is done. And now let's solve our second sub problem. So if somehow we will execute this piece of code only k times, then in that case we will reverse only k element, right? So for that it is very simple. We have to use AND condition, and let's put this condition where count is lesser than k, and count we have not defined, so let's declare count here, which will be 0 initially, and at the end of this we will increment our count. So now if we will execute our program, it will reverse only 3 elements just because k value is 3. So this piece of code will be executing only 3 times, right? So let's see that. Here we go. So we have reversed only 3 elements, 3 2 1. So here we have reversed only one sublist, right, which is having only k node, and now this is the time to reverse every kth node of the linked list. So let's quickly go to our whiteboard and let's see what we need to do in order to achieve this. Okay, so we have taken this linked list as an input, and then our objective is we have to reverse like this: 3 2 1 and 6 5 4 and then 8 7, and this will point to null. And as of now we have reversed this sublist, right, where one next is null. So similarly now we have to reverse sublist number 2 and sublist number 3. Okay, so here 4 next also will point to null. Okay, so let's do that. So it is very clear that we have to execute this while loop 3 times, right? So that means we need to put this piece of code under some condition. So let's use while loop where we'll put this condition, current is not equal to null, and let's put this piece of code inside this. Okay, and now most of you must be thinking that we are using a 2 while loop, so maybe the time complexity would be n square, but it is not, just because if you see the condition over here, in both condition we are using current is not equal to null. So that means as soon as our current pointer will reach to null, so both while loop will not be executed. Now you can see that our current pointer is scanning the entire list only once here, right? And just because of that, the time complexity of this algorithm will be always n. And as I said, this operations we have to execute 3 times now. So now we have to figure out all the relevant element which was part of this. So count, if you see count, so count should be equal to null, before executing this case, right? So instead of initializing this variable here, what we'll do, we will initialize here count equal to 0, and every sub list end of the node will be pointing to null, right? So that means we have to assign back pointer to null here. Okay, so let's remove this, let's save this and execute. And now you can see only last sublist in the output, right? It is happening just because of we have only one head pointer. And if you see the print list, right, so we are using only head. So it is pretty much clear that we have to use a 3 head pointer just because we have a 3 different sublist. So let's create 2 more head pointer here. So let's name it head 2. And remember this, guys, we are doing this just to demonstrate that we have actually reversed 3 sublist, right? And once we achieve that, then we will remove this additional 2 head pointers. Okay, so how we can do that? We have a 3 sublist and we have a 3 head pointers, and to assign that we have to use some kind of counter, right? So let's use another variable sublist count, and initially we can assign as in 0, and after this we will increment our counter. And now here we can use if condition. If sub list count is 1, that means we will execute this piece of code. And else if sublist count is 2, so this is our, so here our back will assign to head 2. And similarly for third case, okay. And now we have to do one more changes. So if you can see the print list, right, inside the print list we are using head pointers. We are assigning head to print and we are using it. So that's how we are printing here. But now we have to print 3 different sublists. So what we can do, we will pass head pointer when calling the print list method. Okay, so let's pass here. So let's make it head, and then accordingly we have to make changes here. So this will be strict, so this will be struct node print, and let's remove this. So let's reverse sub list 1. So this will reverse our sub list 1, and this will reverse our sublist. So this will print our sublist 2, and this will print our sublist 3. Okay guys, so now let's execute this. And now you can see 3 sublist here. Sublist 1, which is 321 null, and sublist 2 654 null, and sublist 3 87, and then null, right? And at the end we have to solve our final sub problem, which is joining this sublist into one list. So let's see how we can do that. So let's observe what is happening here sublist wise. So before reversing any sublist, the starting element will become end element. So before reversing this sublist 1 2 3, 1 was of starting element, and after reversal 1 became end element of this sublist, right? So similarly, if you see 4, which is the starting element before reversal, it will end up end element of that particular sublist, right? Similarly, if you see for 7, so after that we have to do only one thing. As soon as next sublist will get reversed, then after that immediately we have to point end next to the back pointer, right? Just because after reversal, now back pointer position will be here, and our current and front pointer will be pointing to here. And when we join second sublist with the third one, and we have to do the same operation here, and next element will be pointing to back. So that's how we can join our sublist. Before that, let's revert back our code. So let's remove this part, and in print list we don't have to pass head, and here we will declare print, which will be pointing to head. We'll remove these lines as well, and change this. Okay, so we are done. Let's run it first. Let's see whether we have revert back our changes successfully or not. Yeah, we have not removed this one from here. So let's have else condition. We have to use this in future. Let's run it again. And now let's start making changes now based on whatever we have discussed recently. In that we have seen that we have to use a 2 pointer, start and end pointer, right? So let's declare that here. And if you remember, before reversing, we have to assign start pointer to current pointer, right? To current element. So that means start will equal to current. And after reversal, when we are reversing our first sublist, in that case we have to assign our head pointer to a back pointer, which we are doing over here. And immediately after that, our start element will become an end element of this sequence, right? So that means we have to execute this expression and equal to start. And now let's see what's happening if we are doing this operation for second or third sublist. Before doing this assignment operation, we have to assign end next to back, right? Now let's execute this code. Bingo. So here now you can see we have reversed every k node of linked list, right? 321654887. And at the end we have to handle a scenario where if we are passing k value as a negative or 0, or maybe we can pass k which is greater than the length of linked list itself. So normally if k value is greater than the length of the list, so in that case whatever the list we have to reverse accordingly. Okay, but if we have k values negative or 0, then in that case basically we don't have to execute our algorithm. So we can handle that situation here. We have to write or k is lesser than or equal to 0. In that case simply return. Okay, and let's execute it one more time. So this is working fine. And now let's execute our code in worst case scenario. Let's see we are handling very well or not. So let's see if I'm passing k is -1, and now let's see what happened. So now here we have reversed. Basically we have not reversed. Whatever input we had, we have simply written that input, right? Which is fine. And what if we I am passing k equal to 10. So in this case, we have to reverse the entire linked list. So we are getting output as expected. Okay guys, so I think we are done with our coding part here now, and I hope that you liked our explanation part. And remember this, guys, before you start writing code to solve any problem, first try to create sub problems of that problem, and then try to solve the sub problem one by one. Okay, so if you like this, please subscribe our YouTube channel, and please share this video with your friends as well, and see you in next video. Thanks again for watching us.